Welcome to the next lesson of my C++ programming course. At the end of the last video, we managed to set up and build a simple C++ project from a template, which showed a blank window. Today we will start exactly there and explain things a little bit. We will talk about compiling the source code, and we will also go through the code line by line and explain what it does and how it is structured. So, I said that we built an application. What does it even mean? What happens when you push the build button? C++ is a compiled language, which means that the source code has to be first translated into an executable file, which you can later run. This translation is what we call building the project. Another commonly used word is compilation, which is more precisely just one of the build steps. I will present only a simplified explanation of the process at this point. When you start the build, your source code is processed by several compiler tools. They read the code, try to make some sense of it, and if they are successful, they produce an executable file. The tools also combine the code you have written with other necessary components, such as external libraries and C++ runtime itself. Our typical workflow will be to do some changes in the source code, build it, which may take multiple attempts if the compiler reports errors, and then test the resulting application. Let's now have a short look into the folder with the project. There are two files and two subfolders. The main CPP contains the source code of the application, and it is the file that you should worry about the most. The VS Code subfolder contains configuration for Visual Studio Code. File cmakelists.txt contains rules about how to build your project. The build subfolder contains files produced during the compilation. If the compilation is successful, the resulting executable will be among them. If you deleted the build subfolder, it will be created again by the tools. We can now do the same we did last time and observe the process with more insight. Open the project in Visual Studio Code the same way I showed you last time. You should see some log messages at the bottom again, but it should not take long this time. Visual Studio Code just called cmake, which consumed the cmakelists file and generated the project files for your compiler in the build folder. When this is done, you can click the build button in the bottom toolbar. After you do that, your compiler is called and it builds the application executable according to the project files that cmake created before. You can run the executable using Shift F5, like I showed you last time. Now when we have an idea of what we are doing, let's go through the source code of the template project. Open the main CPP file if it is not opened already. As you would have guessed, the source code contains some commands which tell the computer what to do when the application is run, except that we call them statements instead of commands. There are currently just 3 such statements, enclosed in curly braces. C++ uses curly braces to group statements together, and such group is usually called a block. If you enclose several statements in a block, it means they belong together in a certain way. The block in this application is preceded by this line, which basically says this is the block that should be executed when the application is run. We will later see that there can be multiple blocks similar to this one, and the control can transfer from one to the other, so we need a way to mark the entry point. We will now look at the individual statements for a bit. The first line to be executed is cg_create_window. This calls some code defined in the CPP graphics library, which our project uses, and the result is of course creation of the window. Notice that the call is preceded by CG and double colon. The CG is a shorthand that all symbols from the CPP graphics library use to avoid mix-up with symbols from other libraries you might be using, or from C++ itself. It will be helpful for us to distinguish which symbols come from CPP graphics and which are part of C++. Also notice that there is a comma-separated list of arguments enclosed in the parentheses. cg_create_window expects 3 arguments, so it knows how to name the window and what dimensions it should have. The call is ended by a semicolon, which separates individual statements, and it is compulsory. The rules describing where to put semicolons are not easy to explain at this point, but it is quite simple to pick up. The second statement is CG wait until closed. The prefix again says that this calls some CPP graphics code, which will let the window live until the user closes it. Only then will the control continue with the third statement in the line. Notice that CG wait until closed does not accept any arguments, but the empty parentheses of the argument list still have to be there. We will get back to this in a minute. The third statement doesn't have the CG prefix, and it is the only thing of the three which would have worked without the CPP graphics library. This says that the main block should terminate and return control back to the operating system, which effectively means that our application terminates here. The number 0 is reported to the operating system, which is by convention a signal of success. This is how your application could report errors if it was, for example, called by a script. It will not be of much use for us now. This line doesn't actually have to be there, and if it was omitted, the result would be the same. I decided to keep it here for consistency reasons. The only line that I did not explain yet is the one at the very top. Two of the statements that we used were calls of some code from CPP graphics library. Before we can use them, we need to explicitly say that we want to have them available. The information about all things provided by CPP graphics can be found in its so-called header file that the CPP graphics library is distributed with, and you have to include it at the beginning of the source file. You can think of the header file as an index to the library. If we did not include it, the compiler would complain about not knowing what CG create window is. You might have thought that this was already taken care of by the setup of the project, but it was not. All that the project knows are candidate paths where the compiler should look for the header files, which is the reason you can include it without using its absolute path, which you could do, but it's not a good practice. Including header files is something you will be doing often, because it is not specific to external libraries. Even most symbols defined in the standard C++ implementation are only available when respective header files are included. Which header you need to include for which symbol is something the documentation will tell you. Whenever we encounter a need to include an extra header file during the course, I will mention it. Note that there are two variations of the include, one with quotes and one with comparison signs. Use the latter for the standard C++ headers and quotes for everything else, and you should not need to know anything more about it. Now we are finally ready to do some experiments. Let's start with doing what I just mentioned. Remove the include line and try to build the application again. As you can see, the compiler output in the output pane shows something about errors. This will look a bit differently if you use a different compiler, but you should see a description of the error and where it occurred. In this case, it is on line 5. If Visual Studio Code configuration is correct, you should see the same errors extracted in the Problems pane, where clicking the error will take you to the respective place. This will be helpful when the source code gets longer. Dealing with compiler errors is something you will be doing a lot. The most important rules is to always process the errors in the order in which they are reported. The other errors might be a result of the first one, which kicked the compiler off track. In this case, it says that CG is not a class or namespace name. Although you don't know yet what a namespace or a class is, you should understand that there is a problem with the CG prefix. It's not being recognized. It is because the CG prefix itself is unknown to the compiler, which doesn't know to look into the CPP graphics HPP header file. We need to put that line back. Another thing we can try is to remove one of the semicolons and try to build the project. As you can see, the compiler reports very clearly that a semicolon is missing, which in a way also gives a hint about how to fix it. However, if we, for example, omitted this comma here, The error will not be clear at all. It mentions a missing closing parenthesis, although the parentheses are paired correctly. This is a demonstration that the compiler is not clever. It doesn't see ahead. It has no idea what you intended to do. It simply reports places where it failed. Always try to understand what the error is before you try to fix it. I promise to get back to the empty argument list. Let's try what will happen when we forget to put it there. As you can see, the compilation succeeded, but the compiler reported a warning. The code that you wrote is valid C++, which references the bit of code in CPP graphics called wait until closed, but doesn't do anything with it. The compiler correctly guessed that you intended to call it, and warns you that you may be doing something you did not want. If you decide to ignore the warning and run the application, you can see that the window closes immediately, because code to wait until the user closes it was never called. Whenever you get a warning from the compiler, it is a good idea to not ignore it, because it may point to a serious problem which might be difficult to find otherwise. When you see the warning is harmless, it is advisable to alter the code so the warning disappears, because you might later miss an important warning because of it. We will see that later in the course. There are two more general things that I will tell you today about writing C++ code. The first is that C++ language is case sensitive. So if you, for example, capitalize create window, it will not be found, because the actual symbol is lowercase. The second one is that C++ is not very sensitive to whitespace, meaning spaces, tabs, and new lines. For example, if I mangle the code in this way, it will compile and work exactly the same as before. Of course, there are some conventions which say that I should not do this, but the language itself cares little about whitespace. We will get to those conventions later. The only thing that I would like to mention now is a rule about not having multiple statements on the same line, like I now have here. Beginners tend to do this to save lines, but it decreases readability and I highly recommend not getting used to this. I think this was enough for today. To make the course easier to follow, I started to write a document summarizing each lesson so you can get back to it without replaying the whole video. See the description for the link. This is how today's entry looks. There will also be a link to the source code that we create in each lesson, but I will omit it this time because we did not actually write anything. In the next video, I will show you how to draw basic shapes using the CPP graphics library, which will finally open some space for your experiments and creativity. Thanks for watching, and I would be grateful if you also left a comment below.